836-2929.
Thanks, Garrett. 11 minutes after 7 o'clock. If the problems on the 102nd Avenue Bridge are getting you down this morning, you're not alone. There are a lot of unlucky commuters stuck in traffic after a big construction snafu in the West End, and rush hour backups like we're seeing today aren't going anywhere. 4 massive steel girders on the $32 million bridge buckled this weekend, and work could be delayed by 6 months or more. The blunder has triggered an investigation by the city. Here's the city's transportation manager, Barry Belcourt.
It's our responsibility. It's my responsibility to deliver this project. You think we sleep at night? No. The team I'm working with and the contractors, we're embarrassed by this. This is number one priority. Like, how can you just go to sleep and, and I read tweets. Our communication people feed us everything. Like, we live here, we hear everything that's going on, and when you hear people saying, I can't get from the north side to the south side to get the cross center, you don't think that impacts us?
That was the city's transportation manager, Barry Belcourt, talking about buckling on the 102nd Avenue Bridge. Yasser Korany is a forensic structural engineer with Origin and Cause, a firm in Mississauga, Ontario, and Yasser joins me on the line now. Good morning.
Good morning.
Now, the city has said this is cookie-cutter construction. How common is this kind of buckling with a bridge like this?
I would say it is very uncommon. Now we kind of perfected the bridge engineering, and particularly for this kind of relatively small bridge. So that would be very unusual to see.
If you were asked to investigate this, what kind of things would you be looking for?
There are a variety of reasons that could have attributed to this failure. As a seasoned investigator, I know from experience that it is not one single cause. You always keep an open mind, and it is, in most cases, a combination or a sequence of events that led to this failure. So we'll have to go through the process from the beginning, review of the design documents, and make sure that all possible loading scenarios have been considered during design, including loading scenarios that would take place only during construction. And it is not unusual that a structural member would be under a critical loading condition during construction than under actual service conditions.
So, in other words, the steel could be under more duress during the construction and the loading up, putting on there, than it would be when it's actually on the bridge and it opens.
Correct. It might sound funny to a layman person. How is it that during construction the member would be under more stress than actual service? But the structure, bridges included, behave as one coherent unit once all members are in place and connected together.
Mm-hmm.
During construction, they act individually, and there would be factors that could put the individual element under higher stresses during construction than the member would experience during service condition.
Now, the city feels fairly confident in the quality of the steel. They say the materials are likely not to blame. What do you think?
I would tend to agree with this assessment. As an investigator, and I'm sure that the ones who are working currently on this investigation would still look at the material and take some coupons and try to test the material just to rule out this possibility. But steel is one of the most controlled and highest quality structural material that we use. So I would agree that it is unlikely, but as an investigator, you need to keep an open mind and you need to go through all possible causes.
Mm-hmm. Now, just before this problem appeared, the bridge crew had to halt construction for roughly 12 hours due to high winds. How could that have factored into the buckling?
Well, it could, and it certainly, I'm sure that anybody who is involved in this investigation would take a very close look at that. As you reported, only 4 girders sustained this lateral buckling out of 6 girders. The other 2 were traced laterally at the top. Those 4 who sustained buckling were not. it's a question of timing that those four haven't been yet traced, compound with very high-speed winds. And when we refer to these members as simply bridge girders, they are huge members. The height of this girder could be 3 to 4 meters. So they are basically steel walls under very high wind pressure. This particular loading scenario may have not been considered during construction, during design phase.
Now, is there a possibility these could be repaired, or is this unlikely?
Well, in engineering, everything is possible, but we consider the time and money needed. And judging from the photographs I have seen for the extent of the buckling for these members, it would be a very daunting task, really, to try to repair them, fix them. I tend to think now that replacing them would be more cost-effective solution than trying to repair them.
Yasser, thanks very much for weighing in on this morning. We appreciate it.
It has been a pleasure. Thank you for having me.
Yasser Korany is a forensic structural engineer with origin and cause in Mississauga, Ontario. I'm Mark Connolly. You're listening to Edmonton.